We'll continue talking about the sampling, and we're going to use the same example we used in the probability topic, but this time we'll use it in the context of estimating the population, getting estimates for the entire population. If you have the population size for this university, let's say being 8,000 students. So our rule is as simple as that. The population estimate, if you want to get estimate for the entire population, you just get the sample probability, which could be a fraction or it could be a percent. So sample probability, we can say that this could be a fraction, could be a percent, and you multiply it by the population size. So let's say if I told you that I want to find the population of males in this university, and the population, how many males are in this university. So maybe if you have the population size to be 8,000, it's very time consuming to get the 8,000 and to count the males. But if you took a sample of 40, you can estimate the population of males by getting the probability inside the sample. So what is the probability that you have a male inside the sample? So it's 21 out of 40. This could be expressed as a fraction. This could also be expressed as a decimal or a percent. So if you express it as a percent, it's going to be 52.5%. This is what you got from the sample. If you want to estimate for the entire population, you just multiply this number by the entire population size, which is going to be 8,000. So how many males are you going to have if your sample shows that 52.5% are males? You're going to get 4,200. Again, this is an estimate for the entire population. This should not necessarily be the exact number. So also, if you, let's say this time you want to approximate females who are 19 to 21 in the entire population. So the same rule applies. You're going to see in your sample how many were females from 19 to 21. You had 3 out of 40. So you get 3 out of 40 using your sample, and then you multiply it by the entire population, which is 8,000. So if you multiply it by 8,000, then you're approximating that you should have 600 females in the entire population from 19 to 21. And again, this is an estimate. This is not the actual value. So also, there's a concept that I want you to know, which is the margin of error. So sometimes using the sample, we like to put a certain margin of error. So let's say I got that this is 52.5%. Maybe I'm 5% sure of that. So if I gave you a 5% margin of error, this means plus or minus 5%. So if the sample indicates 52.5, then maybe it could be less by 5%, 47.5, or more by 5% to 57.5. So as if you're putting some sort of an error for your estimate. So saying that it might not be for 4,200, but 47.5 of the 8,000, it could be 3,800. Or the percent of population and the males in the population could be as high as 4,600. So it's as if you're putting yourself a range when you're estimating. So once you hear margin of error, you think positive and negative, the percent of the sample probability or the sample percentages. You add and subtract to get an estimate. And always remember that if you want to get an estimate for the population, just get the percent or the probability as a fraction, and you just multiply it by the entire population size.